Let's look at this geometry problem. We have a square with a side length of 10, A, B, C, D, and the point E and F is at the center of the two sides. So we know that BF is 5, FC is 5, EC is 5, ED is 5, right? Um, we need to evaluate the area of this four-sided polygon, um, CEGF, right? So how do we get the area of this polygon, right? So before we actually solve this problem, we need to know something um, about this kind of a shape, this kind of arbitrary four-sided polygon, say A, B, C, D, right? And one of the results that we know is that the ratio of the two triangles, right? The ratio of the areas of the two triangles ADC and ABC. So the area of ABC over the area of ADC. If we compare the areas of these two triangles which share a common base, suppose A and C, AC, right? It's gonna equal to the length from BE, the length of BE divide the length of DE. So that's a result, right? That's a result. How do you prove that, right? How do you prove that? Because these two triangles, ABC and ADC, actually share a common base. So if we treat AC to be the base of both triangles, right, then the ratio of the two areas is going to be equal to the ratio of the two heights, right? This height and this height, right? This is a right angle triangle. So the ratio of the two areas is equal to the ratio of this height and this height, right? And if we look at these two triangles, they are similar triangles because this angle is the same, right? And this angle is also the same, right? So these two triangles are similar to each other, right? So the ratio of the heights are going to equal to the ratio of any of those two sides, right? So it's going to equal to the ratio of this side, this side with respect to this side, right? And also this side with respect to this side, right? And this side is what? This side is BE, and this side is DE. It's based upon the results of similar triangles. So now we know these important results. How do we actually use it to solve this particular problem, right? So how do we actually evaluate the area of this particular shape, right? We can draw a line that connects E and F together, right? And draw a line over here. Then the area of this four-sided polygon is going to equal to the area of this triangle, ECF, plus the area of the triangle EFG, right? So the S of CEGF is going to equal to the triangle ECF plus the triangle EFG, right? And the area of the triangle ECF is easily computed because we know the two sides, and this is the right angle triangle, right? So it's 5 times 5, that's 25, divided by 2, that's 12.5, and then plus the area of EFG. So all we have to do is to actually compute the area of EFG, actually, right? If we know the area of EFG, then we know the area of the whole thing. All we have to do is to add a 12.5 to it, right? So how do we actually compute the area of EFG? If we look at this particular large triangle, AEF, right? This EFG is just a portion of it, right? We know that the area of AEF can be computed, right? Because we know the area of this triangle, we know the area of this triangle, and we know the area of this triangle, right? And we know the area of the entire square, right? It's 100. So all we have to do is to actually subtract all the three triangles. We get the area of AEF, right? So we can get the area of AEF, and if we can get the area of AGF, then we use the area of AEF to subtract the area of AGF, right? Then we get the area of this EFG, right? So what's going to be the area of AEF, this large triangle, right? The area of AEF is going to equal to the area of the square, which is 100, subtract the area of this triangle. This is the right angle triangle, right? So it's ABF, this area. That's 5 times 10 divided by 2, right? That's 25. And then subtract the area of this triangle, which is also 5 times 10 divided by 2, right? It's also 25. And then the area of EFC, right? EFC is what? 5 times 5, 25 divided by 2, 12.5, right? So the result is going to be what? So the area of AEF is going to equal to, so 50 subtract 12.5, that's 37.5, right? So we know the area of AEF now. So now all we have to do is to evaluate the area of AGF. So how are we going to evaluate the area of AGF, right? How are we going to evaluate the area of AGF? Now let's look at the triangle ADF, right? We know the area of ADF because the base is 10, the height is 10, right? So the ADF, let's look at this triangle ADF, right? The area is base 10 times the height 10, right? And then divided by 2, that's 50, right? And this triangle AGF is inside of this ADF. In fact, ADF is made up of AGF and this triangle ADG, right? So it's made up of these two triangles. So if we can figure out the proportion of AGF and ADG and AGF, the ratio of the two areas, right? Then we can actually evaluate the area of AGF, right? So what we want to know is the proportion. So it's going to be the ratio of the triangle ADG over the triangle SAGF, right? So how do we actually figure that out? Right? So these two triangles actually share a common height, right? So if we treat this as the base of this triangle, and GF as the base of AGF, this triangle, then the height is the same, right? The height is going to be the same. So the ratio of the area is going to be the ratio of the two bases, right? So ADG, the length of DG, with respect to the length of GF, right? So DG over GF. So how do we actually evaluate the DG over GF? So now let's look at this particular four-sided polygon, ADEF, right? And use the results we have here. ADEF, this four-sided polygon is made up of two triangles, AD and E, right? AD and E. So AD and E and AE and F, right? So DG over GF should be equal to the area ADE over the area of AEF, right? That's exactly the same kind of results over here. You have two triangles that share a common base. That's AE, right? So ADE has a base AE. AEF also has a base that's AE, right? It's exactly the same as this particular situation here. AC is the shared base, right? So the area of this triangle, the ratio between them is going to equal to DE over EB, right? So the same situation over here. So DG over GF is going to equal to the area of ADE over the area of AEF. We know the area of ADE, right? ADE is just 5 times 10 divided by 2, right? That's 25. And then AEF, we have evaluated AEF already. So AEF, the area of AEF is 37.5, right? 37.5. So if we evaluate that, it's 2 over 3, right? So now we know that the area of this triangle ADG, this triangle, is 2, a factor of 2. Suppose the common factor is A, right? And then this is the area of AEF, no, the area of AGF, this AGF is going to be 3A, right? And the area of the entire triangle ADF is going to be 5A, right? So 5A, ADF equals to, the area of ADF is going to be equal to 5A. So A equals to what? A equals to 10, right? So if A equals to 10, then the area of ADG is going to be 20. The area of AGF is going to be 30, right? So the area of AGF is 30, and the area of AEF is what? AEF is 37.5, right? So now we know the area of AEF is 37.5. The area of AGF is 30, right? So the area of this small triangle EFG is going to be 37.5 subtract 30. That's 7.5, right? So EFG is 7.5. And this area is 12.5, right? 12.5. So add them together. So then our solution is going to be what? It's going to be 20, right? 12.5 plus 7.5 equals to 20, right? And 20 is our result. So the area of this polygon is 20.